Welcome to True Projects. In this video, we are going to explain about a project titled Knee Osteoarthritis using Deep Learning. The project represents a transformative approach to revolutionize the key detection and the diagnosis by harnessing the potential of advanced deep learning algorithms and analyzing the extensive medical imaging data. The project aimed to achieve the precise identification and monitoring of knee osteoarthritis projection. The utilization of deep learning technology promised to significantly enhance the early detection and facilitate the personalized treatment strategy, ultimately resulting in improved patient outcome. This innovation holds the potential to revolutionize the orthopedic medicine, offering the valuable insights and intervention that can positively impact the lives of millions affected by this prevalent joint disease. As a result, this project is poised to usher in a new era of innovation and progress in the field of healthcare, driving advancement in orthopedic care and improving the quality of life for the patients suffering from the knee osteoarthritis. And the primary goal of this groundbreaking project is to pioneer a cutting-edge knee osteoarthritis detection system by harnessing the potential of advanced deep learning algorithm, namely Inception v3, MobileNet v2, and AlexNet, and in conjunction with the powerful ensemble technique. Through meticulous analysis of the medical imaging data, the project to accurately identify and classify the knee osteoarthritis case, enhancing the diagnostic precision and facilitating the personalized treatment plan. Each algorithm, including the Inception v3, MobileNet v2, and AlexNet, will undergo the individual training and rigorous evaluation to ascertain their effectiveness in detecting the case. By utilizing the ensemble technique to combine the strength of these models, the project aimed to achieve the exceptional accuracy and robustness in osteoarthritis detection, ultimately contributing to elevated diagnostic efficiency and elevated standard of patient care in the field of orthopedic medicine. These are the basic requirements that are needed to build this project. The software requirements are Python IDEL with version of 3.7, Anaconda with version of 3.7, or Jupyter Notebook. Hardware requirements are operating system as Windows, processor of minimum Intel i3 and above, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the library. In this step, the Python libraries such as TensorFlow, Keras, NumPy, sklearn are imported. TensorFlow and Keras are used for the deep learning task, NumPy for data manipulation, and sklearn for the model evaluation and the pre-processing. And the second one is importing the dataset. The dataset containing of medical images of knee joints affected by osteoarthritis is imported. These images serve as the input data for the training and testing the deep learning model. And the third one is image scaling and processing. The imported images are pre-processed by scaling them to the standardized size to ensure the uniformity across the dataset. Pre-processing steps include resizing, normalization, and image augmentation technique to augment the training dataset and improve the model generalization. And the fourth step is splitting into the training and the testing. The dataset is divided into the training and the testing set to evaluate the model performance accurately. The training set is used to train the deep learning model, while the testing set is utilized to assess the model ability to generalize the unseen data. And the fifth step is building the model. Various deep learning models are built. The first one is Inception v3. It's a deep learning architecture known for its exceptional performance and the image recognition task. It uses the combination of convolutional and the pooling layer to capture the hierarchical feature from the medical images of the knee joints affected by osteoarthritis. And this project, the Inception v3, will be trained on the evaluator to identify and classify the pattern indicative of the knee osteoarthritis, contributing to the overall accuracy of the knee osteoarthritis detection system. And the second one is MobileNet. It is a lightweight deep learning architecture designed for the efficient deployment on the mobile and the resource-constrained devices. In this project, the mobile net will be utilized to develop a computationally efficient model for this detection. A streamlined structure ensures the faster interference time without compromising on the accuracy, making it valuable candidate for the real-time application. And the third one is MobileNet V2, and it is also the improved version of MobileNet, further optimizing the efficiency and accuracy of the deep learning model. And this project it will be applied to enhance the performance of knee osteoarthritis detection, making it well suitable for both the mobile application and the cloud-based solution. And the fourth one is AlexNet. It is a pioneering deep learning architecture that played a pivotal role in the resurgence of the neural network. Though it has been surpassed by the newer models like Inception V3, but in terms of performance, it is still a relevant choice for this project, providing the valuable insight into the effectiveness of the earlier neural network design. And the last one is of Ensemble. Ensemble learning involves combining of the prediction from the multiple individual models to improve the overall accuracy and robustness. And this project, an ensemble of Inception V3, MobileNet V2, and AlexNet will be created to leverage the strength of each model. The ensemble approach aims to mitigate the individual model bias and uncertainty, resulting in more reliable and accurate knee osteoarthritis detection system. And the next step is training the model. The deep learning model, including of these algorithms, are trained on the training data set. The model learns from the labeled images to recognize and classify it. And the next step is user gives the input. A user-friendly web interface is developed using the Flask, allowing the user to input the medical image for the osteoarthritis prediction. And the next step is the given input is pre-processed for prediction. The user-provided images are pre-processed and scaled to match the format used during the model training. Image pre-processing ensures that the input is compatible with the deep learned model. And the next step is trained model is used for the prediction. The pre-processed images are passed to the trained model, where each model makes the prediction regarding the presence of the knee osteoarthritis in the input image. And the last one is final outcome as displayed. The prediction from the models are combined and the final outcome indicating the likelihood of the knee osteoarthritis as displayed to the user through the web application. This provides the valuable insight into the presence of the condition, aiding the medical professional and making the informed decision and providing the patients with prompt and accurate diagnosis and the treatment. And the execution of the project. To execute the project, first we need to open the code folder. And this is the code folder containing of various files within it. The dataset folder containing of the testing training datasets within it, each containing of the images within it, like of this. And the static folder containing of folders like CSS, images, JavaScript and Bootstrap files within it. And the template folder containing of the HTML documents typically include home, index, notebook, result, sign-in and sign-up pages within it. And the test cases folder containing of images within it that will be used to test the performance of the model. And the app is an py file which likely contains the information related to the front-end logic. It includes the code written in Python that handle the server-side operation such as processing the user request, interacting with the database and generating the dynamic content that to be rendered in the HTML template. And the HY files contains the algorithm information that can be loaded into the project code during the runtime to utilize the trained model for the various tasks, such as making up of the prediction on the new data or performing a specific operation. And the notebook is an IPYNB file which contains a combination of code, graph, output all in one place. It allows the user to write and execute the code in the individual cell, making it a popular choice for the data science. And the signup.db is a file appeared to be the database used to store the user information. And to execute the project, first we need to copy this code folder path. And Open the Anaconda prompt. Here first we need to change the location of the disk. By this command it will change the location, and then write a command cd space and paste this code folder path. By this it changed the current directory to the code folder path, and then write a command that is python space app.py. By using this command it will execute the Python script and perform the runtime check for any syntax errors or the logical issues. And then click on enter button. By running this app.py file, the Flask framework will host the application locally at the default address like this. We need to copy this local link and paste it on any of the web browser as of our choice. I am opening the Google Chrome and pasting this link and click on the enter button. Here we can see the title of the project and contents of sign in and sign up buttons. Click on the sign up button. Here we can see the details that are need to be filled and necessary to create an account. But my account is already created. That's why I'm using the sign in button. Here it redirected to the sign in page containing of some details like username and password that are need to be filled to be signed in. And here I am entering the details of username and password as of admin, and then click on the login button. And here we can see that it will redirect it to the index page containing of the choose file and upload buttons, and click on the choose file button. Here it redirected to this page containing of the images within it. I am selecting one image and then click on the open button and then click on the upload button. Here it redirected to the result page and predicted the uploaded image is of grade 3, that is moderate, like of multiple osteoarthritis, dividing the joint space narrowing with the mild one. And I'm using the try again button to get redirected back to the index page. And here by choosing the file, here we redirected to this folder containing of images within it. I'm selecting the one and then click on the open button and then click on the upload button. It will redirect to the result page, and the image is predicted as of grade 0 with healthy knee image. And by using the try again button, here we redirect back to the index file and then clicking the choose file button and choose any one of this one and then click on the open button and then click on the upload button. Here it redirected and predicted as of grade 2 minimal, and this way we can predict the knee osteoarthritis by using the deep learning algorithms. And in conclusion, the project has been resounding success in advancing the field of medical diagnosis. Leveraging the cutting-edge algorithms such as Inception v3, MobileNet v2 and AlexNet combined with the ensemble technique, we have developed a powerful and accurate knee osteoarthritis detection system. The project's outcome demonstrate the potential of deep learning and the medical imaging analysis, enabling the early and precise diagnosis of the knee osteoarthritis. By providing the timely intervention and the personalized treatment plan, this system holds the promise of significantly improving the patient outcome and enhancing the orthopedic healthcare. The project's success opens the new avenue for the application of the deep learning and the medical diagnostic, paving the way for the more impactful and the transformative innovation and the healthcare industry.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.